Hi, my name's Tristan and this is Brandon, and we're going to be giving a summary video for a recap of lecture 22.
So I'm going to be talking about where we entered into the new module, which explains the spontaneous process and the non-spontaneous process. A spontaneous process is one that occurs naturally without the need of continuous external intervention. In contrast, a non-spontaneous process requires a constant input of energy to sustain it. Without this energy, the process would cease.
Then we discussed that for spontaneity and enthalpy, which many spontaneous processes, such as combustion, are exothermic. Not all spontaneous reactions follow this pattern. An endothermic reaction, where the enthalpy change of the reaction is greater than zero, can also be spontaneous.
Entropy can be understood as measure of how dispersed or spread out the energy in a system is at a specific temperature. It is also described as a thermodynamic quantity that reflects the unavailability of systems' thermal energy to be converted into mechanical work. Often, entropy is interpreted as the degree of disorder or randomness within a system. However, it is changing to provide a simple, comprehensive explanation of what entropy truly represents.
And then we covered several factors that influence entropy change, such as that entropy increases with an increase in temperature, entropy increases as volume expands, it increases when the number of independent particles rises, it increases when the system becomes more disordered, and it increases if there are more ways to arrange atoms or molecules that result in the same state.
So then we went over the second and third law of thermodynamics. I'm going to start with the second, which states that the total entropy of the universe always increases or remains constant but never decreases. The universe can be considered as the sum of a system and its surroundings, with the total entropy change being the sum of entropy changes of the system and the surroundings. A process is considered spontaneous if delta SYS is greater than zero, whereas it is not spontaneous if delta SYS is less than zero. The third law of thermodynamics states that the entropy of a perfect crystal is zero at absolute zero temperature. However, any deviation from this perfect arrangement of particles, such as structural imperfections or molecular motion, will increase the entropy of the system.
And then we wrapped up the lecture basically going over that the entropy of mixing describes the change in entropy that occurs when two or more substances are combined, indicating an increase in or disorder as the components are more randomly arranged. This only applies if all the microstates have identical energy. And finally, we talked about the Boltzmann equation, where it's basically saying the entropy of the system equals the Boltzmann constant times the natural log of the number of microstates. And that is our recap video. Thank you.